All right, team, welcome back. Part 2 today, we're going to start solving these compound inequalities. So the first video was all about just an introduction, what they're made up of. Now we can actually start solving for these compound inequalities. And luckily for us, it's very similar to what we've been doing, just solving regular inequalities, but almost two problems in one. Let me show you what I mean. So to solve compound inequalities, we need to break the inequality into two sections. So we need to break the inequality into two sections. We need to solve for x and graph the solutions. So that's our base here. We need to follow those two steps. Let's start off with one right now. So our first one that we're going to solve is 5x minus 7 is less than 13, or negative 4x plus 3 is greater than 11. Cool. Now, lucky for us, as I said, we need to break up into two sections. They're already in two sections. So this is saying a value for x will work as long as it satisfies this situation or this situation. But these are kind of complicated. So we're going to use SAD-MEG and solve for x to get more specific as to what the value of x needs to be in this situation and in this situation. So we follow the same steps here. We are going to, thinking about SAD-MEG, we're going to add 7 to each side. And we'll get 5x is less than 20. And then this is like saying 5 times x. So we need to do the opposite operation, which is division. So I'm going to divide each side. And I'm going to be left with x is less than 4. So that's it for that one. That's all we need to do. As I said, it's very similar to what we've been doing, but the thing is we just have to do it all over again for the other section. So same idea, thinking about SAD-MEG, pulling the layers away. I'm going to start with that 3. So I'm going to take the 3 away. That's going to leave me with negative 4x is greater than 11 minus 3 is 8. This coefficient in front of the x is negative 4, so I need to divide by that coefficient. Something special here, when I'm dividing by a negative number, I need to flip the sign. So I'm left with x is less than negative 2. Yes, that's what I want. Cool. Okay, so we've done the first step. We've broken the equality into two sections. Then we've solved for x. Now let's just graph the solutions. Same idea as what we've been doing. Let's just do 0 and 4. I've got an open circle. As long as x is less than 4, it works. So everything below 4 is going to work for us. And same thing over here. Zero, negative 2. X needs to be less than negative 2. So all the values below negative 2 will work. Negative 3, negative 4. Now, this is saying all the values of x As long as they satisfy one of these situations, they're going to work. What's special about this case is we actually have a lot of numbers in common, right? Everything below -2 will work. And so everything below 4 is going to work. So for this, actually, we're going to combine these two graphs because we have a lot of options when it comes to the values that are going to work for this situation. Because remember, if either one of these satisfies, it's going to work. So all I'm going to do actually is kind of redraw this one. Because -2 is down here, it's going to work for all of these numbers. Sorry, if it's below 4, it's going to work for -2 as well. So this is kind of a special situation here where we actually are combining the ORs of the two graphs here. Okay, so again, in the last example problem, the two graphs were going in the opposite direction. This one, they're actually going in the same. So we're going to take advantage of that and just have one regular graph. Let's do one more. We're going to do -12 is less than or equal to 7x plus 9, which is also less than 16. So this is one of those and situations, okay? So this x, really what's in the middle here, needs to fall in between -12 and +16. Well, it's a little complicated because it's embedded in this expression in here, so we need to solve. And we're going to do that in the same way that we did the OR. We're going to break it up into two sections. So we're basically going to break it up into one section here. -12 is less than or equal to 7x plus 9. And we're going to break it up into this section too. 7x plus 9 is less than 16. So let's do that. -12 less than or equal to 7x plus 9. Same idea, solving for x using SAD-MEG. I'm going to take 9 away from each side. -12 minus 9 is -21. Less than or equal to 7x. 7x is like multiplication, so I need to do the opposite. I'm going to divide, and I'm left with -3 is less than or equal to x. Okay, so that's half of the problem here. And again, now I'm going to take the other half. I'm going to forget about this half, and I'm just going to solve it from here. So 7x plus 9 is less than 16. Same idea, -9 minus 9. 7x less than 16 minus 9 is 7. Dividing by 7, dividing by 7. X is less than 1. Okay. So now let's draw the solution. So as long as x is greater than -3, but less than 1, the solution is going to work. Let's see what that looks like. I'm going to do them separately, and then we're going to combine them just like what we did. So here's the graph for -3 is less than x. Here's my -3. I'm going to draw a closed circle. And again, just be careful here because normally we've been just going down the number line because that's where it's pointing, but that doesn't work in this case because the x is on the other side. So really we need x to be bigger than -3. That's what this sign says. So in order where is that on the graph? That's everything above -3. So x needs to be above -3, and let's draw the graph for the second part. I've got an open circle at 1. X needs to be less than 1. Since x is on the left-hand side, we can utilize our pointing here, because as long as all the values are below 1, it's going to work. So here are two graphs, and now we can actually combine them because the x needs to satisfy both of these situations. It needs to be above -3, but below 1. So we're going to draw that in our graph and combine them here. Here's 0, here's 1, here's -3. The circles are going to match. So over here, I've got a closed circle at -3. Over here, I've got an open circle at 1. And the numbers in common are going to be our answers that satisfy our problem. And that is it. If I could write it out, I could do that as well. So I could say -3 greater than, less than or equal to x, which is less than 1. So that's what this graph represents. X is in between -3 and +1. And that is to satisfy this initial compound inequality. Any values between -3 and +1 are going to work for this particular situation. Thanks for watching.